Okay, so Unit 7, Lesson 15, Questioning Experimenting. Let's ask the right questions to analyze data from an experiment. 15.1, is it the treatment? A scientist divides 30 strawberry plants into two groups at random. One group of 15 plants will represent the control group and is grown in standard greenhouse conditions. The second group of 15 plants will represent the treatment group and will grow under the same conditions except they are grown in a different type of soil. After 6 weeks, the total weight in grams of the strawberries are measured for each plant. The scientist then performs a randomized experiment to compare the groups. The data are summarized by these statistics and histogram. The mean for the control group is 238.67 grams. The mean for the group with different soil is 347.47 grams. The mean differences in means from randomizing groups is negative 0.540. And then the standard deviation for the differences in means from randomized groups is 29.83 grams. So there is your histogram. Is there evidence that the difference in means from the original groupings is due to the different soil, or is it likely that the difference is due to the way the plants were grouped? All right, so if we look at this histogram, we see that it's a pretty normal distribution. And our mean is, the mean difference is negative 0.540 with a standard deviation of 29.38. All right, so the original difference between the means, which we can get by taking 347.47 minus 238.67, and we end up with 108.8. So our original difference was 108.8. And if we use our calculator to look at the normal distribution with the mean being negative 0.540 and the standard deviation being 29.83, then we can find the probability of getting 108.8 as our difference or a higher difference. And so you can see that probability, the probability is 0.0001. That is a very small probability of getting that value. So this difference, because it's so small, means that it's more likely due to the soil than the way that the plants were grouped, right? So the soil is likely the reason, because that probability of getting such an extreme value for the difference is so small. All right, we are not going to worry about 15.2, but we will take a look at 15.3. All right, so 15.3, using tables for normal distribution areas. A factory produces baseballs. The weights of the baseballs produced are approximately normally distributed with a mean weight of 145 grams and a standard deviation of 2 grams. Official rules require the balls to weigh between 142 and 149 grams. Recall that the proportion of items in an interval of an approximately normally distributed situation is the same as the area under the normal curve. So we have this table here of z-values, or z-scores, that can be used to determine the area under a normal curve bounded by an interval. So you can use this when you don't have technology to be able to help you find it. So first, the relevant values need to be converted to a z-score. A value's z-score represents the number of standard deviations it is above the mean. In the baseball example, the value 147 grams has a z-score of 1 since it is 1 standard deviation above the mean. The value 140 grams has a z-score of negative 2.5 because it is, or since it is 2.5 standard deviations below the mean, so it's negative. All right, so in general, your z-score can be found by using this formula, z equals the value minus the mean equals the standard deviation. And so to make things a little bit easier, I'm going to write the mean here. Since we're scrolling, it'll be easier to see. And then our standard deviation is 2. Okay, so find the z-score for 142 grams. So we're taking 142 minus 145, all divided by 2. And so that's going to give us negative 3 over 2, which is negative 1.5. So then we go over here, our z-score is negative 1.5. So in the hundredths place, we just have a 0. So negative 1.5 would be right there. And so we end up with 0.0668. So there would be about a 6.7% probability of getting, I guess we didn't have to find that yet, but that's okay, 142 grams. All right, so let's do 149 grams. We're just going to find the z-score this time. We're not going to look at the chart. Minus 145 divided by 2, so that gives us 4 over 2, so our z-score is 2. All right, so what value would have a z-score of 1.45? So we're looking at the z is 1.45. We're trying to figure out what x is, but we're subtracting 145 and dividing by 2, right? So then you're just solving for x. So we're going to multiply both sides by 2. So let's see, that gives us 2.9 equals x minus 145. And then when we add 145 to the other side, we get 147.9 is our x value. All right, so number 4, the table gives the area under the normal curve that is less than the given value. Shade the region that is given by the table for the area related to 142. So we already found that area. So our 142, so that actually worked out well. So this is our 142, and this is the area, and that area is 0.0668. And then number 5, use the z-score for 142 grams and the table to find the area under the normal curve that is less than 142, which we already found that. Okay. Number 6, shade the region that is given by the table for the area related to 149 grams. And we used pink for that. 149 grams, our z-score was 2. So we are looking at, all right, so we don't have the positives on this chart. So this is the negative 2. So we're actually going to subtract that from 1. So what was that? 0.0228. So 1 minus 0.0228. All right, and so we're going to shade that region. So that would be like right here. And we're looking at all of those values. And when we subtract, again, that was 1 minus 0.0228. We get 0.9772. Use the two areas to find the area under the normal curve that's between those two. So we would do 0.9772 and then subtract our 0.0668 to get what is left, which is 0.9104. So there's a 91% chance that your baseball would be between 142 and 149 grams. All right, and that is that last question. What proportion of the baseballs that the factory makes are within those official rules? About 91%. And then you can take a look at the summary if you want.